Chapter 5: AI Revolutionizing Personalized Engagement for Consumer-Facing Businesses. Part 2: Telecommunications, Media, and Entertainment. The increasing adoption of AI for various applications in telecommunication, social media, and entertainment markets, the utilization of AI-enabled smartphones, and growing investments in the 5G network are all expected to be contributing significantly to the growth of AI across these markets. Apart from 5G being the next generation technology standard for cellular networks that provide significantly greater bandwidth and download speeds of up to 10 gigabits, it can also be seen as a software-defined network governed by AI with respect to its design, planning, monitoring, management, and optimization, making it effectively the current largest deployment of distributed AI. According to Technavio, the global AI market size in the telecommunication industry will grow by $2.54 billion during 2019 to 2023, whereas Tractica projects $11.2 billion in 2025 and Juniper Research $15 billion by 2024. Technavio also predicted that the global telecom IoT market to post a compound annual growth rate of more than 42% by 2020, with intelligent transportation systems one of the major factors. Some of the key AI use cases in telecommunications include predictive maintenance, monitoring and optimization of network operations, real-time analysis of call direct records, and Internet Protocol detail records for networks, fraud identification and mitigation, cybersecurity, robotic process automation, intelligent virtual assistants for customer service and marketing, intelligent customer relationship management systems, revenue assurance and dynamic pricing, customer churn prevention, customer experience management and service delivery, sentiment analysis, social network analysis, campaign management, customer loyalty, mobile user local analysis, and video compression. Telecommunications service providers are experiencing an increase in demand for improved customer experience and better quality services. By using an AI-driven approach to mine all available relational and non-relational data, a 360-degree view of the customer can be built to provide real-time analytics and insights to provide next best actions that address these customer demands in a personalized fashion. AI-driven solutions can also improve operations and increase revenue through new products and services. Due to the nature of telecommunications and massive customer bases, telecommunication companies have access to vast amounts of mobile network data, voice network data, subscriber data, social network data, and machine-generated data that provides details about mobile internet usage, call detailed records, geolocation, smart device usage, channel interaction, billing, network, set-top box, and machine-to-machine communications. Real-time analytics on these data involves, for example, understanding device usage, customer behavior and preferences, the right channels and social circles, influences, segments, and hotspots in the network performance. The insights generated can drive contextualized, dynamic, and personalized decision recommendations, identify communities, leaders, and followers, and provide a real-time view of the network load heat map and customer experience. As with other customer-facing businesses, the next best action delivers the right offer to the target at the right time to the right location. It also provides customer services representatives and intelligent virtual assistants with the right profile and preferences, manages real-time customer interactions through integrated channels, and offers highly differentiated and customized products and services. As telecommunication companies are adopting technologies such as software-defined networks, network function virtualization, and orchestration, AI is earmarked to play a key role in the integration of these technologies and the automation of networks. According to the IDC, almost 2/3 of network mobile operators are investing in AI systems to improve their infrastructure. One key AI use case is the building of self-optimizing networks to enable operators to automatically optimize the network quality based on traffic and time zone. As an example, Area Networks provides AI-based solutions for automating and optimizing the supply chain that delivers services for digital economy service providers and data center operators. They use AI to dynamically determine the optimal network configuration for a given service request or traffic demand. According to Sedona Systems, their NetFusion platform automatically discovers, aggregates, and analyzes network data from multiple online systems, optical and IP sources to provide a unified, real-time, and accurate network-wide data model. The latter is then consumed via products that reduce the cost, time, complexity, and resources that are needed to forecast, plan, and operate the optimal network infrastructure for delivering the required services, reliability, and performance. Nokia also offers an AI as a service offering delivered through the Microsoft Azure cloud to automate network operations and provide predictive and proactive services across operations and care for improved customer experience, service assurance, increased agility, and reduced costs. As with other equipment-rich industries, predictive maintenance is another major AI application area for telecommunications companies with communication hardware such as cell towers, data center servers, power lines, and set-top boxes. Machine learning-based solutions are utilized to provide real-time monitoring of equipment state, prevent equipment failure, determine causes for deviation in equipment performance, and assist in solving problems proactively. Predictive maintenance solutions aim to understand the process of service degradation before failure and predicting which network elements have a high likelihood of failure within a specified time frame. Avancius describes a predictive maintenance use case with a major European telecom service provider that is in process of transforming its network operations to get ready for 5G and IoT deployment at scale and to deliver better network experience to customers. The outcomes of their AI-driven cognitive assistant for network solution include prediction of 50% plus of the potential impact incidents with greater than 75% accuracy and 35% plus reduction in service impacting incidents and a 0.17% increase in network availability. Affine is another AI-powered predictive maintenance solution that can accurately predict the propensity of telecom tower components due to factors such as fatigue, manufacturing defects, or unsuitable environment in order to prevent business disruption through planned and scheduled maintenance. KPN is a Dutch telecommunications company that is using predictive maintenance to proactively identify issues on the customer side by tracking and tracing behavior such as channel switching on a modem that could cause a Wi-Fi issue. Another AI use case is the detection of fraudulent activities such as illegal access or authorization, stealing or faking profiles, or behavioral fraud that can be prevented by applying anomaly detection solutions that typically make use of unsupervised machine learning to provide real-time alerts when the system sees abnormal or suspicious behavior. AI-driven solutions can also help to reduce churn. According to a 2019 TechC survey, 39% of US citizens who cancelled a contract with a telecoms company in the past 2 years cited customer service as the primary reason, where for the majority cases the contract was cancelled for internet, cable, TV, or phone services. Churn was predominantly due to a negative experience of high customer effort, such as wasting time, multiple calls, incompetent agents, and an inferior self-service option. Telecom services providers are increasingly using machine learning-based solutions to predict customer behavior using customer profile data from a variety of channels, such as online, paid ads, and owned media to targeted customers with a high likelihood to churn. Vodafone follows, for example, this approach to match these customers with appropriate retention plans, discount offerings, and partner company benefits. In another use case, a telecommunications company that had a problem of annual churn rates of about 10%, while the customer base grew at a slower rate of 5% annually. For this particular case, some of the factors impacting churn included customers with a significant number of service calls, those with higher bills, and those with international plans. A churn prediction model helped to capture a significant portion of the potential churners, which led to proactive actions to reduce the churn rate by up to 50%, leading to significant revenue increases. Most telecommunication providers are now deploying intelligent virtual assistants and chatbots to improve customer services that automate and scale responses to support customer requests for setting up, installation, troubleshooting, and maintenance. Some of the major telecom service providers in the US, such as Verizon, AT&T, and Comcast, are all using AI-driven solutions to improve customer services communication, customer engagement, and personalized user experience. Vodafone has also implemented a scalable chatbot called Toby to take care of a range of customer service questions. They have also deployed the AI-powered TechC Via platform, which led to a 12% improvement in first call resolution and 68% improvement in customer satisfaction. Nokia's digital assistant is providing automated assistance to increase the efficiency of network operations center staff and engineers too. For example, diagnose and analyze root causes of network faults. The machine learning-driven virtual assistant reduces wasted time by finding the right information instantly, helps to enforce correct procedures through a knowledge library that includes best practices, and provides access to all relevant tools, documents, and data sources. Robotic process automation is also helping to increase efficiency by making it easier for telecoms to manage repetitive, labor-intensive, and time-consuming back-end operations, such as data entry, billing, order fulfillment, and workforce management. Other use cases include periodic report preparation and dissemination, competitor price checking, software robots that can respond to partner queries, first call resolution, and reducing the manual sales order process effort. One such example is provided by UiPath, which helped an Australian telecoms and media company to reduce costs of approximately 10 full-time equivalent employees by automating its order build process and service removal activity. Celoton claims that their intelligent process automation solutions help to achieve 75% efficiency gains, with accounts payable automation, reduce sales order processing time by 87%, reduce the manual effort in corresponding processing by 85%, and improve customer satisfaction with faster case resolution. With respect to the social media market, Markets forecasts the global AI in this market to grow to $2.2 billion by 2023 at a compound annual growth rate of 28.3% during the 4-year forecasted period. Research and Markets projects that the spend on AI in the media and entertainment industry is expected to increase to almost $2 billion by 2025. Some relevant use cases for deploying AI solutions in the media and entertainment sector includes targeted advertising, facial recognition advertising, marketing and advertising, where machine learning is trained to help develop film trailers and design advertisements, recommending personalized content based on data from user activity and behavior to create a personalized user experience, improving the speed and efficiency of the media production process, and the ability to organize visual assets. Deep video analysis along with translation, transcription, and tagging. Voice-based virtual assistants. Optimized video encoding and delivery. Video quality assessment. Visual recognition. Anomaly detection. Content fingerprinting. Infotainment human-machine interface with virtual reality and augmented reality. Post-production. Content production and management, content consumption and delivery, and data management. The application of AI to improve the digital strategies of news media and publishers are growing in leaps and bounds, with hyper-personalization of reader experiences through machine learning, improving the reader engagement, the elimination of bias and fake news, and automated or robot journalism where news articles are generated by machine learning-based computer programs. News UK has, for example, experimented with a digital butler that gradually learns the preferences, interests, and habits of readers to deliver relevant content in their preferred formats, times, frequencies, and channels. By keeping readers engaged, the news media companies are effectively also reducing churn and can use machine learning systems to also predict and prevent churn. Machine learning can also be used to discover what type of content keeps readers engaged and feed those insights back to the content generation process. Many organizations and companies are also working towards AI-driven solutions to help combat fake news and bias, such as Know Here News, which claims to write an impartial version of a story by applying machine learning to a broad range of news sources, taking into account its trustworthiness, removing potential bias from content, and ensuring impartial headlines. On the automated natural language generation front, OpenAI's GPT-3 is likely leading the pack in this field at the time of writing, with its generative pre-trained transformer deep learning neural network that has 175 billion parameters in its autoregressive language model and trained on the entire English Wikipedia, which is 0.6% of the training set, electronic books, and other web pages. GPT-3 has achieved strong performance on a variety of natural language processing datasets, including question answering and translation, and has the ability to generate samples of news articles that was difficult to distinguish from articles written by humans. Although GPT-3's few-shot learning still makes simple mistakes, struggles on some datasets, and produced some offensive and biased outputs, the model has also demonstrated a high degree of flexibility with other applications that include writing fiction and poems, auto-completing of images, composing guitar tabs, transferring styles for text, answering medical queries, generating code based on text descriptions, solving syntax and language puzzles, and even letting users chat with historical figures. Some other real-world examples include Associated Press that produces automatically generated earning reports, Mid Media's AI bot that writes short text on houses sold in local markets in Sweden, and Washington Post's AI bot that writes less complex stories and covers some localized news. We are also starting to see the use of AI-driven synthesized news anchors reading the news with China's state-run news agency that has debuted 2 news readers to look and sound like the broadcaster's real anchors. AI is also having a direct impact on the field of journalism, where we already see a number of augmented journalism use cases such as natural language processing for topic modeling or sentiment analysis, natural language generation that can, for example, transform data into readable articles, machine learning to enable journalists to identify patterns, trends, and actionable insights from multiple data sources, turn speech into text, and generate text from video and audio, the use of robotic cameras and drones to gather data and information, and support of investigations by, for example, analyzing scenes for faces, objects, text, and more. Jonathan Stray from Columbia Journalism School provided some practice-driven recommendations of how natural language processing can help journalists in analyzing large sets of documents with the Overview platform and produce a story along with applications such as sentiment analysis, topic modeling, text classification, and entity recognition. These recommendations include having a more robust import and analysis of structured and unstructured documents, improved ways of searching through the document set, having better quantitative summaries, be more interactive, and explainability of insights or conclusions. Addressing these will ensure that natural language processing assisted reporting can have an even broader potential and applications for journalists across the spectrum. Many changes to the search engine landscape and shifts in client strategies influence improvements in campaign targeting, but also cause dramatic increases in cost. Competition is getting fierce, with more and more spend shifting towards mobile and shopping ads in the retail sector. From increases in mobile ad inventory to the release of many new shopping ad formats, the race is on to stay competitive. There has been significant increase of paid search and shopping cost per click (CPC) over time. Banner and display advertising is not good in general, as it is not contextually related to the content being read by the visitor. This leads to annoyed visitors and poor click-through rates, unhappy advertisers and low conversion rates, and unhappy publishers and less revenue. An AI-based advertising solution enables significant higher click-through rates, which helps to drive much higher conversions and less CPC with relevant embedded advertising. The system consists of a server-side business component containing the business logic and rules, a client-side ad component responsible for advertisement placement on the publisher's platform and data collection, a customer control panel allowing customers to create ads and campaigns, access statistics, and maintain their account, and an AI component to guide the advertising. Broadcasters can also insert ads into their offerings where real-time machine learning-driven analytics is used to determine which advertisements are ideal and relevant based on the content. AI can also assist in the design of advertisements, ad inventory management, and yield optimization. Robert Tersek, in his article about how AI is completely reinventing media and marketing, believes that synthetic personalities powered by AI to enable hyper-personalization will change the way we learn about new products and how to use them. His primary questions are about AI's ability to improve the workflow in entertainment production and distribution, and the consumer's audience's willingness to engage with and pay for AI-driven automated systems for entertainment. Netflix not only applies AI in every stage of the video delivery and even the quality of their service, but provides an excellent use case for AI-driven personalized content recommendation that drives 75% of viewer activity, as was estimated a few years ago. Apart from personalized movie recommendations, Netflix also uses AI to auto-generate thumbnails from hundreds of video frames and based on what is most recognizable in users' clicks. With respect to streaming quality, Netflix uses past view data to assess bandwidth usage to decide when to cache local servers during peak load times when there is peak demand. An AI use case in film editing is to determine when quality control checks fail, with, for example, synchronizing subtitles to sound or movement. ByteDance TikTok is another example of an AI-driven software-defined media service that uses machine learning to create personalized experiences for users watching music videos or making their own amusing videos. AI is also being used to generate content such as the rapid prototypes produced by the Walt Disney Company to generate rough animation sequences and storyboards. It is also being used by movie production companies in post-production where machine learning is applied to computer-generated imagery characters to mirror the facial expressions and movements of real actors. See, for example, Avengers Infinity War and Avengers Endgame. AI was also effectively used in the movie The Irishman to help create the visual effects of Robert De Niro's de-aging. RCT Studio is also using state-of-the-art AI to create movie experiences with open-ended story worlds that are immersive and interactive where audiences can engage with AI-driven non-players. In addressing the other questions, we already have many examples of people willing to engage with and pay for AI-driven automated systems in the form of smartphones, for example Siri, Google Assistant, etc., intelligent virtual assistants, and chatbots on the web, within apps or messaging services such as Facebook Messenger, Telegram, WhatsApp, WeChat, Slack, etc., or embedded in devices, smart speakers, for example Alexa or Google Home, robot newsreaders, AI-generated music and smart playlists that match tunes and tempo to users' mood and pace on Spotify or YouTube, or AI players in a variety of games, for example, board, card, strategy, and a variety of video games such as action, adventure, shooter, battle, sports, simulations, etc. In the case of video games, we are already accustomed to competing against challenging, human-like AI-driven players, as well as gameplay and difficulty being dynamically adjusted to offer a compelling challenge for gamers of all skill levels. We will also see the infotainment human-machine interface expand into the use of hologram simulations, as we have already seen from celebrity music tours. Virtual reality and augmented reality, for example, Madonna dancing on stage at the Billboard Music Awards with digital versions of herself, that was created with volumetric capture and the AI-driven Unreal Engine. Another extreme example is Hatsune Miku, the Japanese animated singer that is entirely synthetic and doing live performances. AI is also used to help develop augmented and virtual reality content based on the storyline and themes for content, movies, events, virtual reality sports events, fantasy leagues, and gaming. It can also give organizers of these events and virtual reality environments predictive merchandise options and enhance the shopping experience for users. AI-enhanced virtual and augmented reality kiosks at public places such as malls, train stations, and airports can give customers a feel of the products and services. AI-driven visual analysis in movies involves, for example, the tracking of emotions alongside audio analysis of tone, of voice, and music. To give viewers a better feel of an event, a 360-degree view of the live event is captured and then enhanced. This is also how AI is used to draw most of the Earth from satellite photos in the 2020 version of Microsoft Flight Simulator that allows the user to see the entire globe with even real-time weather information. For the virtual world to look like the real one, the AI figured out where to put the trees, roads, and buildings in 3D on top of flat images. With the growing applications of deep learning algorithms such as generative adversarial networks, autoencoders, and convolutional neural networks to exploit its generative power to generate original images, audio, and video, even cogent video without a storyboard or script, or generating animation from recorded audio. We have unfortunately also seen many examples of fake images, audio, and video being generated, which has been called deep fakes and used in false and fabricated news, celebrity pornographic videos, financial fraud, and hoaxes. This has been met with concerns from public, media, academia, industry, and governments and led to responses to detect deep fakes and manipulated content and exploring ways to verify the source of the media using, for example, blockchain. Industry taking action by account suspensions and banning various forms of deep fakes, as well as legal responses such as the Malicious Deepfake Prohibition Act and Deep Fakes Accountability Act in the US. The opportunity with AI-driven infotainment human-machine interaction is to engage in personalized, contextualized, and meaningful ways to serve us instead of the current approach of fighting for our attention and robbing our time. With AI on demand, with lifelike responsiveness in real time, supported by high speed, high bandwidth, and low latency communications infrastructure, and realistic augmented reality overlays on real-world settings, intelligent virtual assistants in the form of personalized synthetic personalities can support us in practical ways via recommendations, advice, filtering of content, relevant contextualized information, demonstrating how to do things, and enriching our experiences.